All right, you guys, so we're gonna try this from your houses instead of the classroom. So I'm gonna lecture you guys on section 6.1. There'll be some other stuff on Google Classroom for you to look at too, the PowerPoint, my worked out solutions, some things like that. But let's get going on 6.1. So in the past, you named and classified polygons. So you looked at triangles, quadrilaterals, pentagons, hexagons, etc., all the ones that we had names for. Now we're going to look at the sum of the measures of the interior angles of a polygon and the sum of the measures of the exterior angles of a polygon. One piece of vocabulary that you guys need to be aware of is diagonal. A diagonal is a line segment that joins two non-adjacent vertices of a polygon. And I'll give you an example of that here in just a little bit. So before we get into any theorems, I want to do a little bit of looking into some of this material. So if I take a look at a polygon that has three sides, okay, or triangle down here, the number of triangles that I can have based upon the diagonals I can draw in is 1. Okay, because I can't draw any diagonals. All of the vertices from one vertex are adjacent, so I can't draw in a diagonal. The sum of the interior angles of any triangle from a couple chapters ago, if you remember, is 180 degrees. The sum of the exterior angles is a little bit different character though. An exterior angle is an angle that is created by me extending a side. Okay, so this would be considered an exterior angle here. So if I do a for instance here, and I draw in 3 exterior angles of this triangle, let's see if we can figure out what they add up to. So I'm going to pick some angles for the interior angles. I know this looks like it might be equilateral, but let's just put some angles in there that we know add up to 180 degrees. One thing you'll notice that the interior angle and its adjacent exterior angle have to be supplementary because they're a linear pair. So if this angle is 60, its adjacent exterior angle has to be 120 degrees. If this one's 70, its adjacent exterior angle is 110. And if this one's 50, its adjacent exterior angle is 130. I'll give you guys a second to think about what those add up to, and then we'll put it in the box. So if you did it correctly, you should find that all 3 of those exterior angles added up to 360 degrees. Okay? Eventually we're going to try to predict what a formula for this. So what if I look at a 4-sided figure? Okay, I picked a rectangle, and so from one vertex I'm going to draw in all of the diagonals I can, which is really just 1. Okay? So the number of triangles that are created in that figure is 2. And since I know that each triangle has an interior angle sum of 180, and I have 2 triangles, 180 times 2 is going to be 360 for the sum of the interior angles of a 4-sided figure. Okay? What about the exterior angles? Well, let's go ahead and create our exterior angles here. Because I gave you a rectangle, all of the interior angles were 90. So all of our exterior angles, being supplementary with the interior angles, 180 minus 90 is 90. And so if all of these are 90, 90 times 4 is 360 degrees for the sum of the exterior angles as well. That looks like maybe that'll be the case for all of them, and we're going to have to investigate a little bit more. Okay? Let's take a look at our 5-sided figure, our pentagon. So if I start at one vertex, and I draw in all of the diagonals that I can, I create 3 triangles. And again, each triangle has an interior sum of 180 degrees, so 180 times 3 triangles is going to be 540 for that pentagon. Okay? What about exterior? Okay, so what we need to do is we need to come up with 4 numbers that add up to 540. Okay, so we're gonna monkey with this a little bit here. So let's say these are 100, gets me to 200, plus 160 is 360. Is that gonna work? Yeah, I'm gonna back up for a second, you guys. Okay. Let's make these 120. So I've got 200, 320, 440, 540. Okay? All right. So if that's the case, finding ones that are supplementary with it, the exterior angles here, this would have to be 80. 120 subtracted from 180, that would be 60. Okay? This one would be 80. This one would be 60. And this one would be 80 as well. And so if I add all 4 of the green ones up, all of the exterior angles, I get 360 degrees. Huh, how about that? So take a minute, pause the video for a second, and think about a rule for all of this stuff. So if you knew you had n number of sides, 6, 7, 8, 9, could you come up with a rule involving n that would give you the number of triangles, the sum of the interior angles, and the sum of the exterior angles? When you're done trying to figure that out, I'll continue and go from there. Okay, so what we should notice, you guys, is that the number of sides compared to the number of triangles, there's always 2 less triangles than the number of sides. And since all of the triangles add up to 180, then the sum of the interior angles is going to be that n number 2, which is n minus 2, which is going to be the number of triangles, times 180. And I think we noticed for the sum of the exterior angles, we were getting 360 no matter how many sides we had. Okay? So think about that as we're moving on. So that leads us to these 2 theorems that are going to be in section 6.1, that the sum of the measures of the interior angles of any polygon is going to be n minus 2 times 180. That's what we just derived on the previous screen. And similarly, the sum of the exterior angles for any polygon is going to be 360, no matter how many sides there are. Let's look at some examples. So we want to find the sum of the measures of the interior angles of a convex nonagon. Well, the first thing we need to do, our formula involves the number of sides, n minus 2 times 180. So nonagon, if you remember, is 9 sides. So taking that into account and using our formula, I can replace n with 9. 9 minus 2 times 180. 9 minus 2, of course, is 7 times 180 is 1260. So if I add up all of the interior angles of a convex nonagon, I'm going to get 1260 degrees. Okay, what about this one? Find the measure of each interior angle of a parallelogram. Okay, well, a parallelogram has 4 sides. Based upon our formula, n minus 2 times 180 should give us 360 for the sum of the interior. I have an expression for each of these, so I'm going to need to add all those expressions together, set it equal to 360 degrees. Okay? So this is just reminding us that 360 is the sum of the interior angles of that quadrilateral. And each of these angles had an expression, and we'll use substitution to replace each angle with the expression. And then I have to simplify. You know, 5 plus 11 is 16, plus 5 is 21, plus 11 is 32x, plus 4 is 8. The rest of the algebra you guys are pretty comfortable with. I'm going to subtract 8. I'm going to divide by 32. X is 11. But remember, they asked me to find the measure of these angles. So I'm going to need to take that 11 and put it back into those expressions. Okay? So use the value and plug them back in. So R is going to be 55, S is going to be 125, T is going to be 55, and U is going to be 125. A check for you would be to add these 4 angles together and make sure that they do add up to 360. If that's the case, we probably did it right. Okay, at this point I'd like you guys to pause the video and try this problem, see how you're doing. and then we'll go through it together. Let's see what we have. So the sum of the measures of the interior angles of a convex octagon. Octagon has 8 sides. Our formula for the sum of the interior angles is n minus 2 times 180. Because an octagon has 8 sides, I can replace that n with an 8. And we're going to take 6 times 180. And if you did it correctly, you should have gotten 1,080, you guys. Similarly here, pause the video, try this problem on your own, and then we'll go through it together. I have a quadrilateral, so when I go n minus 2 times 180, 4 minus 2 times 180 is 360. That's what the sum of all of these angles are going to have to add up to. So all these expressions are going to have to add up to 360. So I'm going to simplify kind of as we go. 6x and 6x is 12x, plus 10x is 22x, plus 3x is 25x. And then I've got this minus 15. That's our expression that's going to have to be equal to 360. I'm going to add 15 to both sides. And then, of course, I'm going to have to divide by 25. And when you do that, you should get 15. So if you got that, pat yourself on the back. Okay, what about a problem like this? A mall is designed so that 5 walkways meet at a food court that is in the shape of a regular pentagon. Find the measure of one of the interior angles. So it's a regular pentagon, meaning all of the angles are congruent. I'm supposed to find one of them. Well, I'm going to give you 2 methods. One method is to find the sum of all of the angles and divide by the number of sides. And we're going to do that first, and then I'll come back with an alternate approach. Okay? So, find the sum of the interior angles of the triangle. Well, that's that n minus 2 times 180, and a pentagon has 5 sides, so 5 minus 2 times 180, we know that all 5 of those angles have to add up to 540 degrees. And since it's a regular polygon, all of the angles are going to have to be equal. I can divide each of those, or divide that sum by 5, and I should get the measure of one interior angle, 108 degrees, okay? An alternate way of doing this, guys, is to involve the exterior angles. And I do this because I know that the exterior angles always add up to 360 degrees. Less for me to remember. So one way of doing this is to take 360 and divide it by 5, which would give me one exterior angle. Because again, I know that the exterior angles add up to 360. I know there's 5 sides in this pentagon. So I divide by 5, excuse me, and I get 72. So that's the measure of one exterior angle. When we're going through and investigating these formulas, we recognize that an interior angle and its adjacent exterior angle are always supplementary. So if I take that exterior angle, subtract it from 180, I'm going to get to the measure of my interior angle. So that's an alternate approach that you may use. Honestly, when it comes to the homework and a test, you guys have to pick a method that works best for you. So pause the video, give this a chance, give this a try, and we'll come back together. So a pottery mold makes bowls that are in the shape of regular heptagon. Find the measure of one of the interior angles of the bowl. A regular heptagon, you guys. Heptagon is 7 sides, if you remember. So I'm going to try to find the measure of one interior angle. So the first thing I'm going to do is I'm going to take 360 and divide it by 7, because a heptagon has 7 sides. This is not going to be a very nice number, you guys. I get...
Attention paras, if there is anyone looking for work right now, Ms. Valheim up in room 2257 could use one person. Again, Ms. Valheim,
sorry, you guys.
one person to help.
Got an announcement going on overhead, so I'm pausing my video for just a second.
Again, Ms. is looking for something to do, 2257 up in the cooking lab for Ms. Valheim. Just one period needed up there.
Okay, so you get 51.43 degrees for that exterior angle. To get to the interior angle from the previous slide, the interior and the exterior angles are supplementary, so we're going to go ahead and subtract from 180. So if I take 180 minus that number that I got, so step 2 here would be to take 180 minus that 51.43, I get that 128.57. It's not a very nice number, but it's what we get when we deal with seven-sided figures. The measure of an interior angle of a regular polygon is 150. Find the number of sides. Again, I'm going to go about this a couple of different ways. One is to use the interior angle number and the sum of the interior angles to help me with that, and one is to involve the exterior angle. So we'll go through the method that involves the interior angles first. Okay? So again, I know that n minus 2 times 180 will get me the sum.
Attention paras again. Ms. Curran could use 4 or 5 pairs in the library.
Sorry guys,
and the
another
number of dogs
announcement.
In the library. Again, there could be 4 to 5 pairs that would go to the library right now if you're looking for something.
Sorry you guys that we have an announcement going on there, but they're using the interior angle sum theorem to write an equation for n, the number of sides. So we know that 180 times n minus 2 is going to give me the total number of interior angles, okay? And S is the total sum, and I know that it's going to be 150 times the number of sides, because they're telling me each interior angle is 150 degrees. So they're going to multiply it by 150 in order to replace S with that. So 150n and S are equivalent here, okay? I can distribute the 180 and get 180n minus 360, and then I have a little bit of algebra to do. I got to move over the 150 and then the 360 to the left side. Divide by 30, and I get 12 for the number of sides. Okay, that's one method. An alternate way of doing this is to involve the exterior angles. So I knew that the interior angle is 150, and I knew its adjacent exterior angle had to be supplementary. So if I subtracted 150 from 180, I got 30 degrees, which would represent the measure of an exterior angle. Okay? And so if I knew that the exterior angle was 30, and I know that all of the exterior angles add up to 360, if I take 360 divided by 30, I get the same 12, which is going to represent the number of exterior angles, but it's also the number of sides. So pause your video, give this number, or give this example 3, check your progress, a shot, and then we'll come back together. Okay, so the measure of an interior angle is 144. I'm supposed to find the number of sides. So I'm going to go 180 minus 144, and I'm going to get 36. And that 36 is going to represent the measure of the adjacent exterior angle, because the interior and exterior angles have to be supplementary.
Mrs. Harris, I could use 1 para to come to the main office right now to help with scanning. Again, I could use 1 para coming to the main office to help with scanning.
Okay, let's continue. Again, that 36 is giving me the measure of my exterior angle. And since all of the exterior angles add up to 360 degrees, if I take 360 and I divide it by 36, I'm going to get the number of sides, okay? And so if I do that, I should get 10. Okay? Find the value of x in the diagram. Well, all of those expressions, you guys, represent exterior angles. And from a previous slide, we learned that the sum of the exterior angles had to be 360 degrees. So you're going to add all these expressions together, set them equal to 360, and then solve for x. Okay? So all of those expressions, we have a lot of simplifying to do. You know, 5 and 4 is 9, and 5 is 14, etc. We can combine our like terms there and get 31x minus 12, which is a much easier equation to solve. Add 12 to both sides, divide by 31. X is 12. If I want to find the measure of each of these, I can put the 12 back into each expression and get my angles, okay? Find the measure of each exterior angle of a regular decagon. This is probably the easiest problem we've done so far, because we know that the sum of the exterior angles is 360. We know a decagon has 10 sides. So if I take 360 and I divide it by 10, I'm going to get the number of sides. Pause your video, give this problem a shot, and we'll come back together. All right, so all of these expressions are exterior angles. So I'm going to add all of these together, set them equal to 360. And so I'm going to kind of simplify as we go. So I've got 2x, 3x, 4x, 6x, 5x, and 5x. So I get 10, 16, 20, 23, 25x. And then I'm going to add up the constants that go with them. 2 and 4 is 6, nothing there. Plus 5 is 11, minus 4 is 7, plus 3 is 10. So plus 10 equals 360. And then I've got some algebra to do. Subtract the 10, and then divide by 25, and I should get x equals 14. Okay, if I wanted to find the measure of the exterior angles, I could then plug that 14 back in and I would be good to go. Find the measure of each exterior angle of a regular pentagon. Pause your video, give this a shot. Okay, the exterior angles add up to 360 degrees. A pentagon has 5 sides, so if I divide that by 5, I'm going to determine the measure of each exterior angle. And I should get 72 when I do that. Okay, so for section 6.1, I want you guys to do page 398, numbers 13 through 47, the odds, and I want you to skip 43. There will be some information for you on the Google Classroom on the stream as to how to upload this information to us. I hope this works out, you guys. Good luck.